Okay, who had one? So tomorrow we get a whole new list of things to memorize, so let's enjoy this while we can. Who had one you couldn't get? 15. 15, all right, let's take a look at 15. Did anybody get 15? Madeline, what was your strategy on 15?
It's not like I don't know the original problem.
Okay, well, I'll write it down up here. Okay, so what'd you do?
No, I never mind. I didn't. Sorry.
Okay, this one isn't super tough, at least not to get started. What's kind of an obvious first thing to do? Multiply them. Now let's FOIL them together and see what we get. What do we get when we FOIL that numerator? 1 minus cosine squared, that's right. Now, when you said that, 1 minus cosine squared, did your heart flutter? What is 1 minus cosine squared? Sine squared. Now tell me about sine over cosine. What is sine over cosine? That is tangent squared, isn't it? There it is. Not even tricky in that one. Some of them definitely have tricky stuff. All right, who else found something? 19. Okay, did anybody get 19?
Have to multiply it out.
Well, let's give it a shot and see. I ran out of room there, but I'm with you, John. I think I will just start over here and see what happens when I distribute or FOIL. So when I FOIL, let's see, here I go. First times first, outsides, insides, and last. Wait a minute. Does that match? That's a classic example of one that looks scary, but it's pretty easy. It certainly looks scary. All right, who else? Let's do another one. Only way we get good is to practice.
25.
25. Okay, now, we did something kind of like 25 yesterday. This is one of those that when you look at it, you think, I don't know what to do. Because there's no foiling. You're not allowed to cross multiply, remember. There's no like squareds, so I can't be substituting like, 1 minus cosine squared is sine squared. I can't do any of that. Does anybody remember what we did yesterday? We actually had one similar to this yesterday. Andrew? Yeah. Be careful, you said on both sides. What you meant was top and bottom, right? Yeah. So we're going to multiply, it doesn't matter which side we start on, I'll just start here since I'm standing here, but we'll multiply the top and bottom by something. And I would suggest that you multiply top and bottom by something that you need over here. So choices would be multiply top and bottom by cosine B, because I need that, or multiply top and bottom by 1 minus sine B, because you need that. Either one's going to give you exactly what you need in the same amount of steps. So it doesn't really matter. but either multiply top and bottom by that or by that. So I'll go ahead, yesterday I multiplied by cosine or something. Today, I'm just gonna go ahead and multiply by 1 minus sine beta. And again, my logic is, I need that in the numerator. I can't think of anything else to do, so I'm just gonna put that in the numerator, because that's what I wanna end up with. Now, that numerator, I'm just gonna stay put for a minute. Tell me about the denominator.
1 minus sine squared.
That foils, right? And that foils into 1 minus sine squared. It makes me leap for joy, because what's 1 minus sine squared? And as soon as I change that denominator to cosine squared, what can I do?
Cancel.
Cancel. I can cancel. And what am I going to be left with when I cancel?
Cosine B.
1 minus sine over cosine, which is what I needed. So this is something you have to remember to do sometimes. If you can't think of anything else, an option that you always have is to multiply top and bottom by the same thing.
Not multiply like cosine B.
You absolutely could multiply top and bottom by cosine, and you would end up doing basically the same work, same thing. Yes, absolutely you can. Katie, you can multiply by anything you want. It just makes sense to multiply by either one of these, since that's where we want to end up with. Okay, that's a good problem. All right, who else?
23.
23 certainly looks scary. But I don't think we need to be afraid of it. Anybody see anything about this problem?
That you should probably get it to cosine.
Yeah,
Cosine.
You could, but as I wrote it down, I felt myself warming up. As I wrote it down, getting all excited. Because what's the numerator?
1.
The numerator is a 1. The numerator is secant squared. That's one of your Pythagorean identities. In fact, I think it may have been on your quiz. 1 plus tangent squared is secant squared. So the numerator is just secant squared. What's the denominator? 1. Done. These are two identities. Just right there. Now, could we change it to sines and cosines? Absolutely. It's just going to be a couple more extra steps. Okay, this is kind of like soccer. Watching me do it doesn't make you good. You have to get out there and do it yourself, okay? You have to practice these, you guys. Katie?
Can we do 11?
We can. It looks big. Let's see what happens. Okay, make sure I copy it right, because this could be bad if I don't, okay? All right, so what's your thought, Katie?
Well, at first I thought to distribute the cosine, but
All right. Oh, let's go ahead and do it.
seems like
Remember, there is no, I mean, you're never going to do wrong distributing. I mean, that's a legal operation. So let's just do it and see what happens. Okay, so I distributed my cosine. Okay, now what's your suggestion?
see if there's. I don't know.
Yes, you do. Isn't this what we want to end up with?
Yeah.
Okay, do you see any tangents or cotangents in that?
No.
Okay, so why don't we change our tangents and cotangents into sines and cosines? Since that's what I want to end up with, I mean, that makes sense, that's logical. Okay, so what's tangent?
Sine over cosine. And then that drop.
And what is cotangent?
Cosine over sine.
Okay, now, does anything simplify?
The cosine in the first one.
Leaves me with sine,
And then the sine in the second,
which leaves me with,
cosine squared.
there we go.
Okay.
Don't make it hard, do what's logical. All right, speaking of hard, let's look at the next page. 36 to 51. I'm going to do 2 with you. These are harder problems. And then I'm going to have you do a couple with your partner. 461. So just kind of look down through that list. 36 to 51. What would you like me to do? 37. Some of these are going to take more steps than we're used to, but that's okay. And some of them won't. Oh man, this one is wild and wacky.
Oh, goodness.
This one's gonna challenge us a little bit. This will not be a test question. This one is a little bit challenging. But
Not a
we can do it.
GTQ?
Huh?
Not a GTQ?
No.
Okay, good.
Anybody have any ideas at all, Maggie?
Do you multiply by the conjugate?
That's not a bad idea. What I need to decide is, am I gonna multiply by the conjugate of the numerator or the conjugate of the denominator? And I'm thinking I wanna multiply by the conjugate of the numerator, so let's give that a shot. Now, some of you are thinking, I never would have thought of that. That's why we practice, so that we see what different opportunities we have. When I wrote down the problem, this is not the way I thought I would start it either. There are lots of ways to start the problem, but here's a new idea. Maggie says I'm going to multiply top and bottom by something. So she said, I'm either going to multiply by sine minus cosine or sine plus cosine. I have chosen to do sine plus cosine. I think that's going to work out for us. By the way, what happens if you choose something that doesn't work out? You just start over, right? You just start over. Okay, well, what do you want to do now? I've done the multiplication.
Can you just distribute it?
Let's FOIL it out, yeah, and see what happens. So the top will be sine squared minus cosine squared. Is that okay with everybody?
Yeah.
And the bottom, now watch it, the bottom will be sine squared plus 2 sine cosine plus cosine squared. Dang, Maggie, you get that. This is an easy way to do this problem. Good call.
Good call, Maggie.
Anything strike you?
The top.
What?
The top
What about the top?
should be like 1.
Well, look at the top of what I want.
This.
There's no cosines up there, right,
There's
in the
no
numerator? So what can I do with a cosine squared?
Get rid of it.
Replace it with
1. Negative 1.
1 minus sine
That's
squared.
2.
1 minus sine squared. Isn't cosine squared the same as 1 minus sine squared? So let's replace that. And again, the reason we need to replace it is because there's no cosines in the answer. There's no cosines up there, so that's got to go someplace. So I'll replace it with 1 minus sine squared. Now, how about the denominator? What do you notice about it? Oh my gosh,
All sides of cosine?
my heart is leaping from my chest. Kids, what have we got down there? We got a 1. That's glorious, great news. We have a 1 and a 2 sine cosine. Isn't that what we want down there?
Yeah.
That's perfect. Okay, what about the numerator? If we distribute the negative, do we have what we need up there too? Life is grand. Awesome. Just makes you happy, doesn't it? All right, let's do one more. Let's pick another one.
Cheated.
33? Okay, 33. Okay, everybody okay with all this strategy here? Follow along, okay? All right, let's look at 33. Okay. What's your thought here, Madeline? Yeah, you have to do something. So that seems like it's something, right? We don't know what's going to happen here, but, okay, so I'm going to FOIL this out. I hope I copied this right. Okay, so here we go. So that's going to be x squared sine squared. That's first times first. Outsides are going to be xy sine cosine plus xy sine cosine plus y squared cosine squared. Oh goodness, that's just the first one. I still need to do the second one.
You can square root everything. Can you? No?
Now, we can square root both sides of an equation, but you can't just square root one side. That doesn't work. Actually, Ben, this is kind of a sophisticated move, but it can be made. For example, if you had a cosine in your problem, you could rewrite that like this. Those are the same thing, right? So you can't just square root. You have to square and square root so they cancel each other out. I don't think we want to do that here. That would be a legal move. just square rooting, it's not. Okay, so I need to FOIL this one too. And sometimes we're just too lazy to do this, right? This is a lot of writing, but it's gotta be done. Gotta be done, so here we go.
This feels like it will.
Okay. So Madeline, I have FOILed, and now I have this big, long, hideous mess. So what am I gonna check to see at this point?
Combine.
Yeah, let's collect like terms. I have an x squared sine squared. And I have a y squared cosine squared. And an x squared cosine squared. And a y squared sine squared. Okay, so I just took care of these. I'm crossing them off because I've written them down. They don't cancel, but they're not like terms. None of those add together. None of these are like terms. Do you understand that?
Yes.
But how about all the rest of these things?
We have two, but mine, just everything.
These two match, don't they?
Put down on the end, right?
And these two match, and those are positive, and these are negative, so they're gone. Those all do cancel. So this is really all that I have left. Now, these do not add together. But is there any way at all I have of combining them? Is there anything at all I could do to these?
Take out group them and then take out x squared.
Okay, so let's group them. So let's group this one and this one and take out the x squared. So Madeline, look, if I group those two and take out the x squared, I'll be left with sine squared plus cosine squared.
Lord.
And if I group these and take out a y squared, I'll be left with cosine squared. Oops, cosine squared, I think that was an alpha, hope it was an alpha, plus sine squared.
Those are both one.
So this is just one, and this is just one, so what do I have left?
X squared plus y squared.
A lot of effort, a lot of writing, but really not hard. Not a hard problem, but a lot of effort. Okay. I want you and the person sitting next to you to try problem number 38. See what you can come up with problem number 38. All right, turn that, change it back in.
So here's the problem with it. One plus. It comes. So I don't know. What do you wanna? Oh, 1 minus cosine. Is this? Aren't these like both sine? 1 plus cosine. Oh, that's not squared. Okay. Sorry. Let's bring a stick over here, right? How do you get stick? Because like if you don't know what to do, you just like pull one up and multiply it kind of thing. You really just like look up the problem and then bring it back together. Bring it back to us all. So you can cosine secant x over. When you're adding these identities together. We're at number 30.
What if we turn both of these? No. If we turn both of these into cosine and secant, drop off. What is
Okay, so that's the problem I got so far.
tangent over?
What? Let me look at some of these formulas here.
Guys, what do you guys do for input?
Yeah, man, if you want the wrong answer, it would actually be.
We didn't conjugate. We did What did you do? We changed the secant to cosine. We did.
Secant is 1 over cosine, so that's how we're going to do this problem. Secant is 1 over cosine, right? Secant is 1 over cosine, so just change these. So what you're going to have to do is basically 1 over cosine.
Which one did I?
Cosine, what's cosine? It's 1 over secant. Cosine is 1 over cosine. Yeah. I know. That hurts your feelings. I see how you plan. So sine of 1 cosine of and 1
JD, you guys got it?
No, we tried 2 different ways.
What did you try?
Multiplying by the what's it called? The opposite.
Okay,
That's not work.
okay. And I can kind of see why maybe that wouldn't work because you have, I mean, when you multiply, you're gonna end up with some squares, right?
Yeah.
So then something's gonna have to happen because there's no squares, whichever way you're going, there's no squares on either side. So if you create squares, you're gonna have to undo that somehow. What was your other thought?
Well, then we thought about switching secant into 1 over cosine.
That is a magnificent idea.
But we just got flustered.
No, don't get flustered. Don't get flustered.
I don't know what to do after that.
See, now
Okay.
you got like 2 fractions
Now
in
listen,
a
you're
fraction.
right. We talked about this yesterday though. When you have fractions inside of fractions, multiply everything by the common denominator so that that will clear those little fractions out.
We definitely did do that.
Do that. Do that. You need to multiply in order to clear those fractions out. So what will happen here? What will I be left with here?
1 plus
Just 1.
cosine x.
Plus cosine x over,
1 minus cosine x.
what was I trying to end up with?
That exact same.
That exact same thing. That exact same thing.
Watch out.
So, let's talk about this for a second, you guys. Don't get so caught up in trying to do tricky fancy stuff that you forget the meat and potatoes. Change into sines and cosines, especially since you have secants and you want cosines. That makes, I mean, secants are 1 over cosine. It makes sense to make that change, right? And then when you have a complex fraction, that's what it's called when you have little fractions inside a big fraction. When you have that, multiply each term by the common denominator, and that will clear out those little fractions for you. And in this case, it gave us what we wanted. Okay? All right, let's try this one more time. Let's see if we have more luck. Let's see. How about, oh yeah, we can try 39. Let's try 39. I think you can get 39. Now look at the problem and think about what would be the common sense way to start.
Start on the left.
Add the fractions together, right. That would make sense. So try it. Brainstorm it with each other, help each other.
So, so they said one goes these. Right. So,
Multiply this one by sine, and then this one over.
okay.
Yes, but can you just add them now? Yeah. No, it's, if you multiply this over here, this times this, that'd be the common denominator. Common denominator is gonna be. So on top, we're gonna have this times.
Serious. Alright, there we go. Alright, that's good. Alright. So 1 over cosine
This one times this.
Ooh.
It's gonna be.
Wait. Let's cancel that out. So that's this is also a sign. This kind of sign. This cancel this one. Squared. I was thought for sure I was high.
So you just take this and then multiply that, and then
Squared G plus 1 plus a squared T over 1 minus 1 minus.
That makes sense. I wrote the wrong problem.
Cancel out with the
Alright, let's see what they have.
So then you could do this times that. So
Yes, and then we're going to put one, into one minus one.
Okay.
So then you have sign.
Common denominator.
Sign T on the bottom. And then you got the bottom.
I think I wrote it down.
Because these are like terms. There's just two of them.
Put that two there.
So we'll just do this.
Yeah.
So, yeah, okay, so yeah, it's 1 times 1 minus 1. You have 1 minus 1 is going to come outside the column. Yeah, so those are 2 minus 1.
Yes.
What's in the 2? Because there's 2 of them. So that's explaining. Just something here, basically. And then they're going to put them together. Oh, just 2. They're going to take the 2 out and then on cosine. So then it would be 1 minus cosine. Or plus 1 cosine. So 1 minus cosine times 1 plus cosine.
You switch this right here.
So then you can cancel out the 1 minus cosine at the bottom and the 1 minus cosine.
This difference to this.
But it's going to be 2 something out of it. That's where you are. Why do you after this, then you unfold but why do you do this? Because you still have to. But you're spinning, but then you put out. Would you put out? No, you still make because this is still just 1. This is just unfolded. Oh, okay. And then you have 1 plus cos. And then the 2 there because they want you to have the 2. So then you just move across out. 1 minus.
Okay, how you coming?
I got it.
You got it? All right, Tom, you want to put it on the board since you got it? Would you put yours up here?
The work's pretty. It's all over the place, but I got it. I wouldn't use my work.
All right, what did you do first?
What did I do first? I got a common denominator.
Okay, so we're going to add these 2 fractions together. Hopefully you all thought about that when you looked and said, oh look, this side has 2 fractions and this side has only 1, so somehow I have to put them together, so I'll do that by addition. So you multiply this one by sine, and this one by 1 minus cosine.
Yeah.
Okay. So your common denominator then was sine 1 minus cosine. Okie dokie. So up here you had sine squared. And here, now what are we going to do here?
You
Foil it. So that's going to give me 1 minus cosine squared, basically.
And then the 1 minus cosine squared is sine squared.
Okay. So this makes the sine squared.
Yeah.
So you basically have 2 sine squared on the top.
Uh-huh.
Okay.
And then can you put the sine squared in parentheses and make it into 1 cosine squared again?
Yep. So now we're going to make that 2 times 1 minus cosine squared
Yeah.
over sine. Okay.
And this is where it gets a little foggy. Can you cross out the 2 and the cosine square and the cosine at the bottom to make
No.
it? You can't?
No, because they're attached to the minuses.
Okay.
What you need to be able to do is factor before you cancel.
Okay.
So we can factor that. How would this parentheses factor?
Would you get a 1 minus cosine and a 1 plus cosine?
Mm-hmm. We talked about that a lot yesterday, remember? Now, these parentheses cancel. You can't cancel part of the parentheses, but you can cancel the whole
Okay,
parentheses.
yeah, it's supposed to be plus anyway. Wow.
Is that what I wanted?
Yeah.
Is that okay with everybody? All right, couple of things. Tonight, I've given you a choice on problems to do, so you don't all have to do the same problems, so you'll just pick the ones you think you can do out there. But tomorrow we're going to have another memorization quiz, because I just graded your quizzes, So tomorrow we'll do it again, and it's not a replacement. This grade counts. But you have a chance tomorrow to get a 10 out of 10 or a 12 out of 10 if there's a bonus, instead of a 4 out of 10, or in some cases, a 2 out of 10, and that was the bonus. Okay? It's really not funny. We need to fix that. So tonight you're going to do a few more identities. Tomorrow we are moving on to the next section.